Can you hear me?
Yes, madam.
Okay, there is a huge rain and thunderstorm, so there is a current failure as too. So sorry for that. Let's start the lecture again. Okay, so we discussing on this example. There are two bags, right? There are two bags, and each bag has three counters: 1, 2, 3, and 1, 2, 3. Right? Right? So a counter is drawn randomly from each bag. From bag 1, also a counter is drawn, and from bag 2, another counter was drawn. Right? So the random variable is the sum of two numbers. The random variable is the sum of two numbers, and they have asked to find the expected value of given random variables and given functions, right? So first we have to clear out what are the possible outcomes, right? So as drawn in this table, this is the first bag and this is the second bag, right? So in each bag there are three counters. Okay. So if the first count of the first bag and the first count of the second bag is chosen, the sum of two numbers on the counters is equals to 2. Right? And if the second count of the first bag and the first count of the second bag is chosen, it is 2 plus 1, 3. And if the third count of the first bag and the first count of the second bag is chosen, then the sum of two numbers on the counters, 3 plus 1, equals to 4. Likewise, we can fill this table. Right? Here 3, 4, 2 plus 2 again 4, 3 plus 2, 5, 5, and 3 plus 3, 6. Right? So now we can write the probability distribution, right? So there are 1, 2, 3, 4, 5 x values we can choose. 2, 3, 4, and 4, 5, and 6. Right? So what is the probability of obtaining 2? Altogether there are 9 observations, 9 possible outcomes. Then 2 obtaining the sum of obtaining the summation as 2, the probability is 1 over 9. And obtaining 3, it is 2 over 9. And obtaining 4, there are 3 possibilities. It is 3 over 9 or 1/3. Obtaining 5, there are 2 times 2 over 9, and 6, 1 over 9. So this is the probability distribution. Right? So now they ask us to find the expected value. of x. As part A, expected value of x, right? That is equals to, according to the expected value equation, expected value from x equals 2 to 6. For all x means 2 to 6. X can take values up from 2 to 6. Summation x into probability of x that is equals to x. Right? So, it is 2 into the probability of px equals 2 is 1 over 9 plus, then x is 3 into the probability of capital X equals to 3. That is 2 over 9 plus 4 into the probability of capital X equals 4. It is 3 over 9. And then 5 into 2 over 9 plus 6 into 1 over 9. This is equals to 4. So the expected value or the mean value, if we draw two counters, the sum of two numbers, the average sum of two numbers is equals to 4. The mean. So this is called the expected value of the random variable, the sum of two numbers on the counters. And part B, the expected value of x squared. Right? So it is equals to summation of x goes from 2 to 6. Just we have to put x square p x equals x. In place of x, we put x squared. So whatever here, we have to put here. Okay. So it is equals to x squared means 2 squared. 2 squared into its probability 1 over 9 plus 3 squared 2 over 9 plus 4 squared 3 over 9 and 5 squared 2 over 9 plus 6 squared 1 over 9. Okay. So it is equals to 156 over 9, 17.33. Then part C, expected value of 2x squared minus, there should be capital, right? These ones are capitals. The random variable is denoted using capital X, right? Okay, try to find this. So you can separate this one into 3 parts and get 2, 6, and 5 out and find the expected values as before. Or else, there is an easy way to find that, right? So we know that this is equals to two into expected value of x squared. Why? Since 2 is a constant, we can get 2 out and it is expected value of x squared, right? Then minus 6 expected value of x. plus the expected value of a constant is the constant itself. So it is 5. Right? So it can be written as two into 156/9 minus 6 into 4 The answer is 15.67. Right? Okay. So that is how we find expected value for discrete random variables. Now we find the expected value of continuous random variables. So if x is a continuous random variable and simple fx is the value of its probability density at x, the expected value of x is given by, the expected value of x is minus infinity to plus infinity, the integration x fx dx. Right? So in the discrete case, we wrote the expected value, right? In discrete case, expected value of x was equals to summation of all x into fx. Right? Summation. Instead of the summation, here we put the integration for all x instead of all x minus infinity to plus infinity. X fx dx. Right? In place of summation, the summation replaced by the integration. That is the only difference. Denote this by mu equals ex, which is also called the mean of the distribution. If x is a continuous variable with probability density fx, the expected value of the function gx is given by, if we want to find the expected value of a function, then in place of x, we put that function, gx. Right? So it is easy, the same concept, but instead of the summation, in the continuous case, we put integration from minus infinity to plus infinity in x, integration by x, right? So I think it's clear. So again, there are the same result is valid for the continuous case. I just explained. Right here, when x is a continuous random variable, the expected value of a constant is the constant itself. Right? The proof is also same. The expected value of a, we write a here. Then a into fx dx. We can get a out since it is a constant. So for all x, that means from minus infinity to plus infinity, the fx dx is equals to 1. Therefore, the expected value of a constant is a constant itself in the continuous case as well. And in the results too, expected value of ax is the a into expected value of x if a is a constant. The same scenario here as in discrete case. I think I need not, it need not to be explained, right? So it is very clear. We can get a out, and x fx dx means again the expected value of x. Okay, result 3, expected value of ax plus b is the a into expected value of x plus b. We can separate the ax plus b into two parts as ax and b. Then ax into fx dx, b into fx dx. So a into x fx dx is the a into expected value of x, and b is a constant. So the constant expected value of a constant is the constant itself. It's b a into ex plus b, right? And result 4, if there are two functions called f1 and f2, then expected value of f1x plus f2x, we can separate again into 2, and finally we can write it as the separate expected values for two functions, expected value of f1x and expected value of f2x, right? So another example is given, right? So the continuous random variable x has a probability density function. The density function is given. In earlier case, the probability distribution we found it, right? In the die case, we found the probability distribution. Here, in continuous case, the probability density function is given. So it is 1 over 20 x plus 3 for the range 0 and 4. Okay. So we are going to find the expected value. So part A, we want to find the expected value of x. So if expected value of x, we can write it as for all x, or minus infinity to plus infinity. It is x into fx dx. Okay. So since the x is in between 0 and 4, we can write this as 0 to 4 x into the function 1 over 20 sorry, x plus 3 dx. Right? So we can take 1 over 20 out, and it is 0 to 4 x squared plus 3x dx and 1/20. It is x cubed into 3 plus 3 x squared over 2. Substitute the values 0 to 4, right? 0 and 4. So this is equals to 2.266, I guess. Is that so? Okay, now trying to find expected value of x squared. I'll give you 5 minutes. Send me answers. Those who have finished, send me your answers, please. Yes, Savini, you are correct. Do the next one as well. Yes, Sevandi, right? කවුරු හරි ඉන්නවද ටියුට් එක සබ්මිට් කරන්න බැරි වුණා නේ. LMS එකේ ප්‍රශ්න නිසා මට එක්කෙනෙක් මේල් කරලා තිබුණා. තව එක්කෙනෙක් මැසේජ් එකක් දාලා තිබුණා එයාට බැරි වුණා කියලා. හැබැයි ඒ කියන්නේ මොකක් හරි එහෙම ඉෂුව එකක් තියෙනවා නම් ඩියු ටයිම් එකට කලින් මට ඉන්ෆෝම් කරන්න ඕනේ. නේද? දැන් අද 12ට කලින් කියලානේ තිබුණේ. එතකොට 12න් පස්සේ මට ඉන්ෆෝම් කරලා තේරුමක් නැහැ. මම දන්නේ නැහැ එතකොට ඇත්තටම ජෙනුයින් කේස් එකක්ද නැද්ද කියලා. එහෙම ප්‍රශ්නයක් තියෙනවා නම් මේ ඒ ඩියු ටයිම් එකට කලින් මට ඉන්ෆෝම් කරන්න ඕනේ. එහෙම නැත්නම් ඔයගොල්ලෝ ඩීන්ස් ඔෆිස් එකට කතා කරලා එතනදී ඒ ඔයගොල්ලෝගේ LMS එකේ මොකක් හරි ප්‍රශ්නයක් තියෙනවා නම් තියනවාද කියලා චෙක් කරගන්න. එහෙම නැත්නම් මට 12ට කලින් කතා කරන්න. right? ඒ කියන්නේ ඩියු ටයිම් එකට කලින් කතා කරලා කියන්නේ ඊට පස්සේ දැන් අද එක කමක් නැහැ. අද කාට හරි සබ්මිට් කරන්න බැරි වුණ කෙනෙක් ඉන්නවා නම් now it's time 4:45. So before 6 p.m. හයට lectures තියෙනවද? සාමාන්‍යයෙන් පස්සේ lectures තියෙනවද?
Yes, ma'am.
right. එහෙනම් before 8 p.m. එහෙම කාටම හරි tute එක submit කරන්න බැරි වුණා නම් මම mail එකක් දානවා, mail address එකක් දානවා. ඒකට mail එකක් දාන්න tute එක. හැබැයි මේ පාරට විතරයි. ඊළඟ tutes මම mail එකෙන් submit කරනවා බාරගන්නේ නැහැ. මොකක් හරි ප්‍රශ්නයක් තියෙනවා නම් due time එකට කලින් කියන්න. due time එකට පස්සේ එන ප්‍රශ්න වලට මම respond කරන්නේ නැහැ. හරිද? ඔයගොල්ලෝගේ discipline කියන එක number 1 තියෙන්න ඕනේ. due time එකක් අපි දෙන්නේ ඒක නිසානේ. right? so due time එකට කලින් මට inform කරන්න ඕනේ LMS එකේ ප්‍රශ්න submit කරන්න බැරි ප්‍රශ්න තියෙනවා නම්. so මම message එකක් දාන්නම්. මම දැම්මම දාන්නම් මේ mail address එක කාට හරි බැරි වුණා නම් අද රෑ 8ට කලින් මේ ඒ දීලා තියෙන mail එකට send කරන්න. This is only for this time, right? Only for the tutorial number 1. Some of your answers are not correct. Yes, Shavini, you are correct. Yes, most of you are correct. So part B, I'll just some important points only. X integration all x squared fx dx. So 1/20 0 to 4 x squared into 1/20 x plus 3 dx. Right? Okay. Okay, that is about expected values, right? So the other property of a distribution is, and another important property is the variance, right? Variance. So variance is defined as variance of x is equals to expected value of x minus mu squared. So it is defined by expected value of x minus mu squared. So it is equals to, we can write it as it's equals to e x squared minus ex, the whole thing squared, right? You have to keep in memory the equation. This is the equation for the variance, right? Right? So if you want to know how this equation comes, so you know that mu is equals to, you can be written as expected value of x, right? So the variance x can be written as expected value of x minus expected value of x, the whole thing squared, right? Then if we square this, x squared minus 2 into expected value of x minus the expected value of x, the whole thing squared, right? So if we expand this, expected value of x squared minus, so here there should be 2 into x into expected value of x, right? So here it becomes 2 into, we can get the expected value of x out and the expected value of x minus expected value of x squared. So this is equals to expected value of x squared minus 2 squared minus expected value of x, all things squared. This should be plus, right? So We can write it as expected value of x squared to expected value of x or whole thing squared plus expected value of x whole thing squared. It is minus expected value of the whole thing squared. I think now it's clear how this comes. Right? This is how we find the variance. The variance is, either you can say it is expected value of x minus mu the whole thing squared, or the expected value of x squared minus expected value of x the whole thing squared. Right? So again, as in expected value, there are some results on variance as well. So variance of a constant, variance of any constant is equals to 0, right? So it is clear now, when a constant, there is no any variance, right? So variance A, we can write it as expected value of A squared minus expected value of A the whole thing squared. So the expected value of a constant is the constant itself. So we can write this one as A squared, and expected value of A is A. Squared of expected value of A is A squared. So it becomes 0. So this is as expected since the constant does not vary. Since the constant does not vary, the variance is definitely 0. Right? Then variance of A into x, where A is a constant, it is when we get A out, it becomes squared, right? We can't, so in the expected value, if we write if expected value of AX, where A is a constant, we can write it as A into expected value of x. But here, A becomes squared. Let's see how it happens. Variance of AX. So a variance can be written as expected value of x squared minus expected value of x, the whole thing squared, right? So expected value of AX, expected value of AX squared minus, so we can write this as E squared AX, right? Expected value of x, the whole thing squared. We can write it as the notation E squared AX. So here this becomes A squared x, right? Expected, so I'll write it here. So variance of expected value of AX squared. So that means expected value of A squared x squared, no? Right? Minus expected value of AX, the whole thing squared, right? So since A is a constant, A squared is also a constant. So this can be written as A squared expected value of x squared minus, right? So here expected value of AX is the A into expected value of x. The whole thing squared means this becomes A squared expected value of x the whole thing squared. So it becomes a squared. If we get a squared out, expected value of x squared minus expected value of x, the whole thing squared. So this is variance of x. So it becomes a squared variance of x. Right? Then next result, variance of ax plus b, right? So we can write it as this. So I think now you can understand it, right? The same procedure. So we can write expected value of ax plus b squared as x squared, a squared x squared plus 2abx plus b squared, right? And ax plus b as a into expected value of x plus b squared. So we can get a out here, a squared out here, and here 2ab both are constants. We can get them out, and expected value of x plus b squared. Expected value of a constant is squared, so b squared is again a constant, then expected value of b squared is b squared. Then in the other part, a squared expected value of x whole thing squared minus 2ab, again we can get it out, and expected value of x minus b squared, right? Then using few calculations, we can obtain this a squared variance x. Give me 1 minute, please. Okay, is it clear now? Any problem? I guess no, right? Okay, look at this example. let x be the discrete random variable number of heads when 2 points are tossed, right? So we know that the probability distribution is number of heads. So there are 0 possibility, there are no heads, then there may be 1 head and there may be 2 heads when tossing 2 coins, right? So the probabilities are 1/4, 2/4 and 1/4. So that is the probability distribution related to that random variable x, number of heads when 2 coins are tossed. So we have to find the variance of x and variance of 3x minus 2, right? So we can find the variance. So we have to find variance of x. So it is expected value of x squared minus the expected value of all things squared, right? So first we can find what is expected value of x. So it is summation. Since it is a discrete case, we use the summation, right? X goes from 0 to 2, x p, x equals x. So it is 0 into 1/4 plus 1 into 1/2 plus 2 into 1/4. So it is equals to 1, right? Then next we can find what is ex squared. It is summation goes from 0 to 2, x squared px equals x. It is equals to 0 squared 1/4 plus 1 squared 1/2, 2 squared 1/4. It is 3/2, right? Now we can write variance of x, that is expected value of x squared 3/2 minus e squared x means the expected value of x, the whole thing squared, that is 1 squared. So it is half. Right? Then part D, variance of 3x minus 2. Right? So according to that results, we can take the constant before the x out. but we have to square it, right? Variance of x. So 9 into variance of x is 0.5, that is 4.5. So for the continuous case, nothing is going to be changed, but in place of summation, you just need to put the integration, right? So I think now you can find the variance of the earlier example we discussed in the continuous case, right? So that is all about the expected value and variance. So in next lecture, we are going to learn the moments, a new section, moments, right? The chapter 2, the last part is about moments. So next Monday, we are going to discuss that thing. So far, if you have any question, you can ask me, right? If you have any question, you can ask me now. And also, I would like to know whether you have a problem in understanding my lectures, the way I conduct my lectures. So if the voice is not clear, if the speed is so high or so low, so any feedback regarding my lectures, any feedback, please, if you have any good or positive or negative, anything, right? So I ask you to email me any feedback, right? It may be negative or positive, right? So I can change my patterns of teaching methods. So it helped me to improve the method of teaching. So please, if you have any feedbacks regarding my lectures, please email me, right? Okay, I'll give you some more questions in near future, right? So I'll discuss some questions related to those chapters soon after we finish this chapter, right? No. It's just write the answer. No need to write using result 1, result 2 likewise. So no need to mention in that from result 1, result 2. You can just apply the result. Okay, definitely I'll upload all the lectures. I have recorded all the lectures. I'll upload them. Physically present campus 30th. 30th. Do you ask to attend lectures physically on 30th? It's not clear.
No, ma'am, we have to hand over applications in 30th.
169. 20. Yes. Karyam Prashnak, do you have any?
No, ma'am, we were asked to, no, madam, we were asked to attend the university physically to hand over the documents for the enrollment of.
ඔක තිස්සෙන්දට කලින් මේ එන්න කියලා තියෙනවද මොකක් හරි ඔයගොල්ලන්ට මේ කැම්පස් එකට ෆිසිකලි ඉන්න එහෙම ඉන්ෆෝම් කරලා තියෙනවද?
No, madam, no.
Okay. So I had to hand over documents for registration on 30th November. All right. I city to hand over the documents on me. I like it. So those who can't join to the lectures, I'll upload the materials and the video as well, right? Okay. Any questions? Other than that? So I hope no then, right? Okay. Then shall we stop for today? Okay, I will try to upload the lecture materials before the lecture, right? So today morning itself, I knew that the tutor cannot attend to lectures today, so that's why it was late. So I'll try my best to upload the materials the day before the lecture. Yeah. Okay, let's wind up for today now. Okay, thank you for participating.
Thank you, madam.
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 Thank you, madam.